This is the Harrier jump jet, a plane that needs no runway at all. It can do things that no other in-service jet plane can perform. It can take off vertically. It can take off with a short runway. It can even hover. Built originally in the 1960s, the Harrier jump jet revolutionized fighter plane design. Over 800 Harriers have been in service around the globe, taking off from land and sea.
My name's Squadron Leader Jim Provost. I'm a Harrier pilot on one squadron. I've been flying for approximately 12 years, and I joined the Harrier in 1994. The Harrier concept came about many, many years ago during the Cold War. Its design was to be able to take off from very short surfaces, to land vertically in case there were no runways to make use of. And we're talking about a concept that was in the 50s, and yet it's still going into the 21st century. What makes the Harrier special is the fact that it can land vertically. It can land on a ship, it can land in a clearing in a wood, which makes it very special.
The reason that the Harrier can perform these incredible maneuvers is its extraordinary engine system. There are 2 air intakes, but only one massive Rolls-Royce Pegasus engine.
First point to note is that there's only one engine on the Harrier. People often make the mistake of thinking that there are 4, but there aren't. You see through the intake here, there's the Pegasus engine. It's a big engine and provides all of the thrust for the aircraft. If we look down the right-hand side, we can see what we call the nozzles. We've got a hot nozzle at the back here and a cold nozzle at the front. Same on both sides, so we have 4 nozzles that take the thrust from the one engine. What that does, it provides normal thrust for forward flight, just like any other fast jet. And if we bring the nozzles down, which you can control from the cockpit, that gives you your thrust for your vertical landings and your vertical takeoff.
The plane's entire weight is supported on the downward thrust of its engine.
When the Harrier comes to the hover, obviously most of the thrust goes from the engine to the 4 nozzles on the fuselage. What we need to do once it's in the hover is control it. The way we do that is by diverting some of the thrust to the puffer ducts, as we call them. We have puffer ducts in the wingtips, puffer ducts in the tail, and also the nose. And what that does is provide control in all axes whilst it's in the hover. If you didn't have that, then the aircraft would just fall out of the sky. It'd be on a pillar of thrust, and you'd not be able to control the roll, or the pitch, or the yaw.
By blasting small amounts of thrust out of these puffer ducts, the pilot can balance the plane in hover and can even use them to perform delicate maneuvers. He can even get it to fly backwards. However, if the Harrier is fully loaded with weapons and fuel, it hasn't enough thrust to take off vertically, so it uses a traditional takeoff, but with a much shorter run, just 454 meters. When hovering, the Harrier needs constant pilot input. This is particularly true when operating from an aircraft carrier.
The thing can't hover and land by itself, so there's lots of things that the pilot needs to do. He's got to be able to maneuver the aircraft safely over a very small area and be able to land it. So there is a lot of pilot input that you don't get on other aircraft types. Harrier can go anywhere in the world. It can operate from almost any terrain. It's proved itself in desert warfare, temperate climates, the Arctic. It can also operate from the ship. It can land on almost any surface, and it can carry a large weapon load. We can compete with the very best. We can go a long way, we can go very high, and we can bring precision weapons, which is where warfare is, to the fight.
The Harrier is getting old, and by modern standards requires a huge amount of pilot input just to keep the plane in the air, when they should be concentrating on the enemy. Also, its inability to go faster than the speed of sound could put it at a disadvantage when up against faster jets. The answer is the F-35, the Joint Strike Fighter, the only aircraft in the world that is supersonic and can take off and land vertically.
I'm Lieutenant Colonel Art Tomasetti, United States Marine Corps, test pilot for the Joint Strike Fighter program.
In 2001, Lieutenant Colonel Tomasetti achieved a real milestone in aviation history. Flying the prototype JSF, he was the first man to do a short takeoff, followed by supersonic flight, finishing with a vertical landing, all in one mission.
It showed the versatility of the airplane to be able to have a supersonic capability, but still have the capability to land anywhere, take off from just about anywhere it provides you.
The JSF achieved this extraordinary feat due to its unique engine system, which is based on the same principles as the Harrier. The engine has a large rear nozzle that can be directed both backwards and downwards. But it also incorporates a new piece of technology that the Harrier doesn't have, a massive fan just behind the pilot, powered by the engine.
The lit fan allows a tremendous amount of thrust to be harnessed out of the propulsion system and give the airplane a capability to do its vertical part of its work with a lot more payload than we've ever experienced in airplanes before.
To take off vertically, hover, and land, doors open along the fuselage, and air is sucked down by the fan and pushed out the bottom of the plane. So the aircraft balances on two pillars of thrust.
The rear nozzle, in addition to pointing straight down, can twist in yaw, which allows the airplane to pivot in the sky and perform 360-degree turns. The airplane can fly sideways, the airplane can fly backwards just by vectoring the rear nozzle.
This propulsion system is controlled by computers.
Unlike previous airplanes, for example in the Harrier, where the pilot has been responsible for controlling the thrust vector and making the inputs required to have the airplane do all those maneuvers, the JSF airplane, the pilot's just going to ask for go forward, go backwards, turn left, turn right, and the computers now are responsible for wiggling all the parts in the airplane necessary to achieve that maneuver.
The use of onboard computers to help fly the plane is now essential in all strike planes and has totally revolutionized the face of air combat. Computers are now used to fly planes that humans simply couldn't keep in the sky.